Okay, let's restart and actually start. Oh, wait. Open addressing. Open addressing is where all elements occupy a hash table itself. That is, each table entry contains an element or is nil, but all the elements that we are querying are in this table. When searching for elements, we simply look at the table slots until we find it, or we've basically made certain it's not there. We don't actually have to go through and see the different linked lists and all that. The no elements are stored outside, unlike chaining. Thus, open addressing can fill up fast, and no further insertions can be made once it is filled up. Little factor A can never exceed 1. So one consequence is this. So the max number of rows that you have, m over n, or I forgot if it was the other way around, the number of slots that you have can never be over the number of data you have can never exceed the number of slots you have. Of course, we could store linked list in for chaining inside the hash table, the otherwise unused hash slots. But the advantage of open addressing is it avoids pointers altogether. All we need to do is just go through and compute which one it is. Compute the sequences of slots to be examined. Extra memory freed by storing pointers provides a hash table with a larger number of slots with the same amount of memory, potentially yielding fewer collisions and faster retrieval. To perform insertions using open addressing, we successfully examine our probe hash table until we find an empty slot in which to put the key. Instead of being fixed in the order of 0 to n minus 1, which requires O of n surge time, the sequence of positions depends on the key being inserted. Determine which slots to probe. We extend the hash function to include the probe number, starting from 0. As a second input, so this is for insertion, basically. They're saying they have to actually look in the hash table to see which is an open column. And based on that, if they find the open column, which is O of n time, because it's essentially just random, we have to extend a hash function to include the probe number. And this hash function becomes this. With open addressing, we require that every key k probe sequence can be a permutation of this right here. So that every hash table position is eventually considered as a slot for a new key as tables fill up. In the following pseudocode, we assume that elements in the hash table T are keys with no satellite information. The key K is identical to the element containing key K. Each slot contains either a key or nil. The hash insert procedure takes as input a hash table T and a key K. Either returns slot number where T stores key K or flags an error because hash table is already full. This is how it inserts it. Starting at I equals 0, repeat until if it's found nil, then we're replacing with the element J. We're taking I as the hash function. Else we just increase 1 until I equals M. And then if there is nothing, then we have to throw an error. So if you look at this, this is probably O of n time. Again, like they said earlier. Algorithm for key K probes, same sequence as the slots insertion when key K was inserted. Therefore, search can terminate unsuccessfully if it doesn't find it. Procedure hash search takes as input hash table T and key K returning J if it finds the slots J containing key K or nil. Yo, guess how much are you doing this miles for walking thing? Can you join? We get a pizza party if we win.
What is our ranking right now?
Third place.
We're third place. Oh, who is above us?
Fourth west.
Yeah.
Oh wait, fourth east and someone else. I don't know.
Shit, how down? What's it called?
We're 300.